Welcome to this video on the standardized normal distribution and the StatCrunch normal calculator. After watching this video, you will be able to demonstrate how the normal calculator can be used with z-scores. Use the normal calculator in StatCrunch settings to find the probability of an event using both standard and between settings. The normal distribution versus the standardized normal distribution. Here is a graph of the normal distribution, and superimposed on it is the empirical rule. Notice that the normal distribution is centered around the population mean. Then, as we move away from the mean, we are counting integer number of standard deviations. Notice that the x-axis is the random variable, and it will be in whatever units the random variable is in. Let's compare this to the standardized normal distribution. First of all, we can see overall we have the same curve or the same shape, which is the normal distribution. What's different, however, is the x-axis. Over here, the normal distribution is centered around the mean, but once we standardize that as a z-score, this new curve is centered around 0. Also, the tick marks are counting by ones, because remember, this is the number of standard deviations you are away from the mean. So here, our x-axis is the z-score, which is a unitless measure, or the standardized score versus the random variable that's in the context of the problem. Introducing the normal calculator in StatCrunch. Previously, we have used the empirical rule to find the area under the normal curve. This is a very limited approach, however, as it relies on values being a whole number of standard deviations from the mean. A more robust and less computationally intensive approach is using a normal calculator, such as the one in StatCrunch. Let's open StatCrunch and learn how to use the normal calculator. Go to statcrunch.com, log into the site, click on Open StatCrunch. Once you're in StatCrunch, hover over Stat, Calculators, and then go to Normal. Here you can see I've already navigated to the site statcrunch.com and I've already logged in. Next, I will click on this orange icon that says Open StatCrunch. Once I have a new StatCrunch window, I'm going to come up here to the menu and go over to Stat, then Calculators, and then I'm going to go down to Normal. Notice that these options are alphabetically organized, so Normal is about 2/3 of the way down. Once we click on that, this screen shows up. I strongly recommend anytime you're using a new tool in StatCrunch, take a few minutes, turn off the video, and just play around with the different options. Type in different values here, click on the drop-down menus, select all the options, just to familiarize yourself with this new tool. So let's get started. First of all, you can notice here that the x-axis has already been labeled with z-scores. It's centered around 0, and it has intervals of 1, 2, 3, and so on. In other words, it already has a mean of 0 and a standard deviation of 1. Let's go down to this next row. If I click on this inequality symbol, notice that there is a drop-down menu. Unlike discrete probability distributions, where we had many different options, this time we only have two options. We have less than or equal to or greater than or equal to. Those are the only two things that are available to us. Let's see what happens when we change from less than or equal to greater than or equal to. Notice that the shaded area on the graph moves to the right. Now let's try changing this value. So let's hit compute. Notice now that the graph is shaded to the right of 1, and this number, this probability, shows up here, and it's different from what we had before. What if we change it to less than or equal to 1? Again, now it's shading to the left of this value, and notice that the probability here changes. Again, please take some time, explore this tool on your own, and familiarize yourself with it before you move to the next step in the lesson. Standardized normal distribution, example 1, area to the left of a z-score. Determine the area under the standard normal curve that lies to the left of the following z-scores. Round all answers to 2 decimal places. So here we have A, B, and C. So this represents three different problems that we need to do. Let's start out with problem A. So our z-score is 0.45, and we want to find the area to the left. So I'm back in StatCrunch. The mean and the standard deviation are not going to change because we're working with z-scores. What is going to change is this value right here, and instead of whatever was there, I'm going to type in 0.45. The other thing we have to decide is which inequality symbol to use. An easy way to remember it is if you want it to go to the left, then you're going to select less than. So let's hit compute. Notice that the left half of the graph, or the left side of the graph, is shaded, which is exactly what we're looking for. We want the area to the left of 0.45. So this is the correct answer here, and the area under the curve, which remember is the same as the probability, is about 0.67. So we can say that the probability of finding a z-score that's less than 0.45 is about 67%. Now let's move on to the second problem. This time we have a z-score of 1.23. So we need to go back to StatCrunch and put that into our normal calculator. So in our normal calculator, we need to now go to this field right here and type in 1.23 and hit compute. Now you can see that the area to the left of 1.23 is about 0.89. So we see here we have our answer for part B, so let's go on to part C. This time we have a negative z-score. Z is equal to negative 1.25. Again, we have to return to StatCrunch to calculate the area. So in StatCrunch, once again we come here, we delete what was there, and type in negative 1.25 and hit compute. This time, again, the left part of the graph is shaded, and the probability is right around 11%. So we have our answer for part C. Standardized normal distribution example 2, area to the right of a z-score. Determine the area under the standard normal curve that lies to the right of the following z-scores. Round all answers to 2 decimal places. Again, we have the exact same z-scores. Why are we doing the same problem a second time? Well, the answer is this time we're typing in the same z-scores, but we want the area to the right of these values. So let's hop over to StatCrunch and see what we need to do. So the first z-score we're interested in is 0.45. Now if I hit compute, just as we have it, then once again the left half of the graph is shaded. How can we change that? Well, remember, this inequality sign is actually a drop-down menu. So if we come down here and select greater than or equal to, then the calculator will give us the area to the right of that z-score, which as you can see here is about 0.33%. So the area to the right of z equals 0.45 is about 0.33 or 33%. Let's move to the next example. Z is equal to 1.23. So back in StatCrunch, we type in 1.23 and we hit compute. This time, our inequality sign was already a greater than, so we don't need to change anything else. So as you can see here, the probability is about 11%. So now we have the answer for part A and part B. Let's go ahead and do the last part, part C. Z equals negative 1.25. So I'm going to type in negative 1.25 into our calculator. And again, we already have the greater than or equal to selected, so we don't have to change that. As you can see here, the probability, or the area to the right of this value, is about 0.89. So now we've found the answers to all three questions. On this screen, I've arranged the answers to the first three questions above and the answers to the second set of three questions below. So let's look at these two areas here. Notice that the z-score is the same, 0.45 and 0.45. The only difference between the graphs is that the top one is showing us the area to the left of z equals 0.45, and this graph is showing us the area to the right of 0.45. What happens when we add 67% and 33%? Notice that that gives us 100%, because remember the total area under the curve always has to add up to 1 or 100%. How about the next set? Again, we have the same z-score, upstairs and downstairs, 1.23 and 1.23. The only difference is this graph is shading to the left and this graph is shading to the right. What happens when we add 89% and 11%? That's right, the probabilities also sum to 100%. How about the last pair of graphs? Again, z equals negative 1.25 is upstairs and downstairs. Again, the only difference is that the top graph shades to the left of this value and the bottom graph shades to the right. Is 11% plus 89% equal to 100%? It is. Again, the probabilities sum to 100% because the area under the curve has to add up to 100%. Standardized normal distribution example 3, area between two z-scores, symmetric. Determine the area under the standard normal curve that lies between z equals negative 1.5 and z equals 1.5. Let's go to StatCrunch and see if we can figure out how to do this. The problem statement gives us two z-scores, but as you can see in this screen right here, we only have room for one z-score. What we need to do is we need to come up here and there's a standard button and there's a between button. Click on the between button and see what happens. All of a sudden, everything changes. Now there are two different values and our random variable x is being sandwiched in between those. Also notice that the graph changes. There's now two lines and the graph is shading in between these two lines. So let's try typing in negative 1.5 here and positive 1.5 right there and hit compute. Notice that the graph shades exactly the area that we're interested in, the area between z equals negative 1.5 and z equals positive 1.5. So as we can see from this graph, the probability is about 0.87 or 87%. Determine the area under the standard curve to the left of z equals negative 1.5 or the right of z equals 1.5. Well, let's draw a picture of what that means. We're still cutting the graph at negative 1.5 and positive 1.5, but now the area we're interested in isn't this shaded red region, but rather this white region over here to the left of that red region, and also the white region over here to the right of positive 1.5. Now, unfortunately, there isn't any way, at least that I know of, to make StatCrunch shade these two regions. So we have to be a little bit clever and do something else. Do you have any ideas? Well, what we can do is we can use the complement rule. So remember, if I add up the area, the total area under the curve, that's going to give me 1 or 100%. So I could take 1 or 100% and subtract off this shaded area, which is, as we found in the previous problem, 0.87. Doing that, we find that the area in these two unshaded regions is 0.13 or 13%. Let's do one more example like this. Determine the area under the standard normal curve that lies between z equals negative 0.7 and z equals positive 1.59. So again, in the StatCrunch calculator, we click on the between setting, and then we come down here and we type in negative 0.70 and 1.59, and then we hit compute. And as you can see, the probability is about 70%. So now we are asked to determine the area under the standard normal curve to the left of z equals negative 0.7 or to the right of z equals 1.59. So again, we have the same graph. However, the area we're now interested in are the two unshaded regions to the left and right of this shaded region. And again, there's no way that I know of to make StatCrunch shade these two regions. So what we have to do is once again use the complement rule. So we have 1 minus 0.7, which is about 30%. You should now be able to demonstrate how the normal calculator can be used with z-scores. Use the normal calculator in StatCrunch settings to find the probability of an event using both standard and between settings.